Hey, Annalise, I have your review here. I wanted to go over a couple of the questions because in looking at your first attempt and this attempt, there's at least one question that you're missing in both instances, so I wanted to clear that up. I also applaud you for your perseverance in wanting to get a good grade on this. So the first one is asking if the function in the graph is non-linear. And so I think you maybe read, is it linear? So you said, no, it's not linear because it doesn't have a constant rate of change. It does not have a constant rate of change, but that's what makes it nonlinear. So this one we actually should have said yes, because again, it's asking, is it non-linear? That means, is it not a straight line? Yes, it is not a straight line because it does not have a constant rate of change. Question 7 is talking about the quadrants on the coordinate plane and if you graph certain points and which ones are going to be guaranteed to stay in the same quadrant. So remember, quadrants are numbered with Roman numerals working clockwise, counterclockwise around the grid starting in the upper right-hand corner. So what you've selected is that JJ and KK would be in the same quadrant, but depending on their signs, so if J is positive but K is negative, they're not necessarily going to lie in the same quadrant because J could be negative, again, K could be positive. That would put them in different quadrants. Anything really with addition or subtraction, you also run the risk of those points not being in the same quadrant. Again, if in this third option, if JK, if you add those together and you get a negative, but then you have a positive 3, that puts you in one quadrant. But if you have a positive 3 and then a negative number, that puts you in another quadrant. So this option down here is really the only one where your signs aren't going to change. So if J is positive here and we multiply it by 3, J is positive here, we take 3 and divide it by J, you're still going to have a positive number. Same with K, if we multiply it by 3 or divide 3 by K, you're still going to have the same sign because that's really what this is about, is which option are my signs not going to change, and that's that multiplication and division. Oh, and I guess I skipped over this second one. The reason why this second one doesn't work is if J and K are both negative, that puts you in the third quadrant, but then if you multiply two negatives together, now you have positives, which would then move this point into the first quadrant. So there's only one that works there. And then the last question, I definitely noticed this one got missed earlier, and it took me a while because I was trying to remember what parts of 8th grade have we had, what did we do in 7th grade. So I know that through your work probably in 7th grade with proportional relationships, you might see something like this. I'm just going to add this last column on here, right? That if she spends $60, how many people attended? So a lot of students start with this 20 to 60 and they say, oh, well, that's times 3. So then I can take this 10 and also multiply it by 3 and I can get 30, right? So 30 people, it's going to cost $60. But this is not a proportional relationship, which means this graph doesn't necessarily do this. This graph could start somewhere like this. Now it's still going to be linear. It's still linear because we do have a constant rate of change, but it doesn't necessarily start at the origin. And since it doesn't start at the origin, it's not proportional. So this answer of 30 does not work. So instead, what do we do when we don't know if it's proportional, or how do we figure it out? So instead, we still want this $60 amount, and we want to know how many people are going to attend. So now if we look at the rate of change, now I'm going to look at what is the rate of change, because here it is constant, which again is how I knew it was linear. So if we go up by 3 here, we go up by 3 here, that gives me a rate of change of 1. If we go up by 3 here, we go up by 3 here, that's up by 2, we go up by 2 on the left and 2 on the right. That's another rate of change of 1. And you can do it from 25 to 60, you can do it from 15 to 60, it doesn't matter, but it will work every time. So from 25 to 60, we're increasing it by 45, just kidding, $35. So then I need to do that same thing over here. To keep that rate of change 1, then I have to go up 35 from 15. And if I add 35 to 15, I do get 50. So this answer is actually 50 people attending. Again, it's not a proportional relationship. And you can see that early on, right? It's not proportional because if it's $15 for 5 people, that's $3 a person. But if you go down the table and you look here, now it's only $20 for 10 people. That's $2 a person. So we're not proportional, which is how we can use then that concept of the rate of change. You can also see that these are always $10 more. It's 10 more than the people attending, right? 8 plus 10 is 18, 10 plus 10 is 20. And again, this one only works because the rate of change happens to be 1. So for every additional person, it's going to cost an extra $1, but that doesn't start until that first person. So something's costing her $10 at the very, very beginning, but we don't have that part of the story. So I hope this is helpful. I did reset it for you. Let me know if you have any other questions.